Humans are funny creatures. We spend an awful lot of time looking up. For millennia, we have craned our necks toward that vast, dark quilt pricked with tiny lights, wondering what it all means. It's a primal curiosity, a deep-seated itch that scratching only seems to make worse. What's out there? Are we alone? Could we go see for ourselves? This isn't just a scientific question, it's a deeply human one. It's the same impulse that pushed our ancestors over the next hill, across the unforgiving ocean, and into every nook and cranny of this planet. The cosmos is simply the next and biggest hill to conquer. It represents the ultimate unknown, a challenge to our ingenuity. This yearning isn't just for poets and philosophers, it's baked into our DNA. The drive to explore is a survival mechanism. By the year 2050, this age-old dream isn't just a dream anymore. It's a blueprint. It's a project plan with budgets and timelines. The pull of the void has become an engineering problem, and it's one we are finally, thrillingly close to solving in a meaningful way. Getting off this rock is hard. Gravity is a relentless and clingy partner, and it takes a colossal amount of energy to break free from its embrace. For decades, our method has been, to put it crudely, a controlled explosion. We fill giant tubes with volatile chemicals, light a match, and hope the resulting blast points in the right direction. By 2050, the rockets are just bigger, more efficient, and most importantly, reusable. The sight of a massive booster descending from the sky to land gracefully on its tail is no longer a miracle of engineering. It's routine. Once we're out of Earth's gravitational well, however, the game changes. By 2050, nuclear thermal propulsion has become the workhorse of the inner solar system. These engines use a fission reactor to superheat a propellant like hydrogen, creating a much more powerful and sustained thrust. This cuts the travel time to Mars from a soul-crushing 9 months down to a more manageable 3 or 4. This isn't just about getting there faster, it's about getting there safer. Solar electric propulsion systems, with their gentle but persistent push from ionized xenon gas, have become standard for moving heavy equipment into place around the solar system. Experimental ships are even testing advanced plasma drives and, on the very fringe, early-stage fusion concepts. The journey itself is becoming a key area of innovation. Getting there is no longer just a prelude to the real mission. It's a demonstration of the incredible technological symphony that will define humanity's expansion into the cosmos. The moon is no longer just a beautiful light in our sky or a collection of dusty footprints from a bygone era. By 2050, it is a bustling, permanently occupied outpost. Shackleton Station, nestled near the lunar South Pole, is a testament to international cooperation. The deep, permanently shadowed craters nearby hold the most precious resource in space: water ice. Life at Shackleton Station is a strange mix of cutting-edge science and frontier ruggedness. The habitats are a combination of inflatable structures brought from Earth and modules three-dimensional printed on site using lunar regolith. The view from your habitat window is starkly beautiful and profoundly alien. The sky is a perfect, velvety black, even during the day, and the Earth hangs like a giant swirling blue and white marble in the darkness. The 1/6 gravity is a constant source of both amusement and physiological challenge. You can bound across the surface with giant leaps, but your muscles and bones are in a constant state of protest. Beyond the science, the moon has become a critical stepping stone. By 2050, the moon is not the destination. It is the first essential stop on the road that leads out into the solar system. If the moon is our structured, scientific suburb, Mars is the raw, untamed wilderness. By 2050, the initial tentative outpost has grown into a small but hardy settlement, Perseverance Valley. The primary goal of the first Martian colonists is survival, which hinges on one thing: becoming farmers. The initial habitats include large, pressurized greenhouses where the first Martian crops are grown. Afternoons are for exploration and science. Geologists venture out in pressurized rovers, drilling core samples and searching for signs of past or even present microbial life in subterranean brine pockets. The psychological dimension of being a Martian is immense. Earth is not a friendly blue marble in the sky. It's a tiny, distant star, indistinguishable from the others without a telescope. This has forged a unique culture among the settlers, one of radical self-reliance, intense camaraderie, and a deep, profound connection to their new home. They are the first generation of a new branch of humanity, the Martians. Their struggles and triumphs on this dusty frontier are writing the first chapter of our story as a multi-planetary species. For most of human history, the title of astronaut was reserved for a tiny, elite group of specialists. But by 2050, that has fundamentally changed. Space is no longer just for the scientists and the explorers, it's for the vacationers too. For the price of a luxury world cruise, ordinary, well, albeit wealthy, citizens can book a week-long stay at one of several commercial space stations. These aren't cramped government-issued tin cans, they're designed for comfort. The journey begins with a surprisingly smooth ride aboard a fully reusable spaceplane that takes off from a conventional runway, accelerates to hypersonic speeds, and then gracefully docks with the station just a few hours later. Once you're aboard, the first thing you notice is the view. The station features massive windows, offering a constantly changing panorama of the Earth below. You watch continents glide by, witness thunderstorms flashing like silent fireworks. Life in the Space Hotel is a playground of microgravity. You can perform effortless acrobatics that would be impossible on Earth, play zero-G sports in a dedicated recreational module, or simply float peacefully in your cabin. For those wanting a bigger thrill, tethered spacewalks are on offer, letting you float outside the station in a simplified spacesuit, with nothing but a clear visor between you and the cosmos. While humans are taking their first bold steps onto the Moon and Mars, our robotic emissaries are venturing far deeper into the solar system and beyond. By the year 2050, the line between a robot and an explorer has blurred completely. Imagine a probe exploring the methane seas of Saturn's moon Titan. It can identify a scientifically interesting geological formation, decide on the best course of action, and even deploy a smaller drone to investigate it, all without a single command from mission control. The stars of this new era of exploration are the Great Space Telescopes. The successor to the James Webb Space Telescope, aptly named the Cosmic Origins Observatory, uses a massive segmented mirror to peer into the atmospheres of exoplanets dozens of light years away. It doesn't just find these planets, it analyzes the light passing through their air, searching for the chemical fingerprints of life, biosignatures like oxygen, methane, and water vapor. And perhaps most excitingly, a cryobot has finally drilled through the thick ice shell of Jupiter's moon Europa, deploying a submersible to explore the dark, potentially life-bearing ocean beneath. These robotic explorers are more than just tools, they are our partners in discovery. Together, human and machine are pulling back the curtain on the cosmos at a rate that was unimaginable just a few decades ago. The grand adventure of space exploration isn't just happening out there, it's creating powerful echoes that are profoundly reshaping life back here on Earth. The technological push required to keep people alive in a vacuum has become a wellspring of innovation. The closed-loop life support systems perfected for Martian greenhouses are revolutionizing agriculture in arid regions, enabling us to grow food with just a fraction of the water we used to need. The advanced robotics developed for asteroid mining are being adapted for everything from deep-sea construction to disaster relief, sending machines into places too dangerous for people. The economic impacts are equally transformative. A whole new space economy has emerged, valued in the trillions of dollars. This has created millions of high-tech jobs, not just for rocket scientists and astronauts, but for software developers, materials scientists, roboticists. But perhaps the most significant impact is on our perspective. The constant stream of images of Earth from orbit has reinforced a sense of global unity and fragility. From space, political borders vanish. This new cosmic perspective inspires a new generation of students to pursue careers in science, technology, engineering, and mathematics. It provides a grand unifying project for humanity, a positive vision of the future that transcends national and cultural divides. For all its inspiring promise, our push into the cosmos by 2050 is not without its monumental risks and ethical quandaries. Space is, and always will be, an environment of unforgiving danger. A single system failure, a micrometeoroid impact, or a solar flare can mean the difference between a routine mission and a catastrophe. The loss of a crew on Mars, isolated and beyond any hope of immediate rescue, would be a global tragedy of immense proportions. Beyond the physical dangers, there are profound ethical questions. The principle of planetary protection is a major point of debate. When we send humans and machines to Mars or Europa, we risk contaminating these worlds with earthly microbes before we can determine if native life exists. The militarization and commercialization of space also present significant challenges. Who owns the resources of an asteroid? What jurisdiction applies to a crime committed on a private space station? The Outer Space Treaty of 1967 is being stretched to its limits. Finally, there's the question of priorities. The immense cost of space exploration is often criticized when there are so many pressing problems here on Earth. Is it morally justifiable to spend trillions of dollars building a base on Mars while people on Earth lack clean water? Our journey to the stars is a reflection of our values, and we must continually ask ourselves if we are making the right choices, ensuring that the benefits of this grand adventure are shared by all of humanity, not just a select few. As we stand in 2050 and look out across this new human domain, it's clear that space is no longer a distant dream. It's a place of work, a destination for travel, and a new home for pioneers. It is an integral and growing part of the human experience. The story being written in the dust of Mars and the vacuum of orbit is not just the story of astronauts and engineers, it is our story. It belongs to everyone. The future of humanity in space is not a predetermined path that we simply watch unfold on a screen. It's a choice, or really a series of choices that we are all making every single day, right now. You don't need to be a rocket scientist to have a voice in this future. The artists who paint the vistas of new worlds, the writers who imagine the lives of the first Martians, and the teachers who inspire their students with lessons about the planets are all shaping our collective vision. The ethicists and lawyers who grapple with the new rules of this frontier are ensuring that we expand into space responsibly and peacefully. The voters and taxpayers who support the funding for scientific missions are casting a ballot for a future of curiosity and discovery. The crucial questions are now before us. What kind of society do we want to build beyond Earth? Will it be one of cooperation or conflict? Will we treat new worlds as pristine wildernesses to be preserved or as resources to be exploited? So look up at the moon, track the faint red dot of Mars as it moves across the constellations, and contemplate the infinite possibilities scattered across the night sky. That is your frontier. Your future is being built there. Whether you become an engineer who designs the next generation of spacecraft, an artist who inspires the journey, or simply an informed citizen who advocates for a hopeful and inclusive path forward, you have a ticket to the stars. The great shared adventure of our time has begun, and the most important question is not what space will look like in the future, but what role you will play in creating it.